Have you ever stood outside on a clear night, looked up at the sky, and felt something strange? Not wonder, not peace, but a quiet, creeping unease. Like the universe was trying to tell you something you were not quite ready to hear. Most people look at the stars and feel small. But what if I told you that the real terror is not in how small we are? It is in what happens when those stars go out. One by one. All of them. Every single one. And that this is not a metaphor, not a poem, not a religious prophecy. It is physics. It is mathematics. It is the most certain thing science has ever told us about the future of everything that exists. We live in an age that worships the present. We obsess over what is happening right now, the news, the notifications, the endless scroll of a world that never stops moving. But there is a story unfolding on a timescale so vast that the human mind genuinely cannot hold it. A story that began long before the first human drew breath, and that will continue long after the last star in the universe has burned itself out and gone cold and dark forever. And here is the thing that keeps certain physicists awake at night. We know how that story ends. We have worked out the math. We have traced the trajectory. And the ending is not dramatic. It is not a bang or a fire or a divine judgment. It is something far more unsettling. It is silence. Perfect, absolute, eternal silence. But let us not start at the end. Let us start where you are right now, because that is the only place any story can honestly begin. Right now, as you read these words, the universe is approximately 13.8 billion years old. That number is so large it has essentially no meaning to the human brain. We evolved to count things we could see and touch. Berries, enemies, days. We did not evolve to comprehend 13.8 billion years. So let me try to give you a sense of it another way. If you compress the entire history of the universe into a single calendar year, with the Big Bang happening at midnight on January 1st, then the entire history of human civilization, every empire, every war, every invention, every love story, every tragedy, would fit into the last 14 seconds of December 31st. The pyramids were built less than a second ago. The Roman Empire rose and fell in the blink of an eye. Everything you have ever known, everything your ancestors ever knew, everything that has ever been written down or remembered or passed from one generation to the next, all of it happened in the final heartbeat of a year that began with an explosion of unimaginable energy and has been slowly, steadily, magnificently unfolding ever since. And yet, as old as the universe is, it is still young. Cosmically speaking, we are living in the morning. The stars are still burning. The galaxies are still forming. Life, at least here and perhaps elsewhere, is still possible. We are in what astronomers sometimes call the Stellaniferous Era, the age of stars. It is the era we were born into, the era that made us possible, the era that feels so permanent and eternal that we cannot imagine it ever ending. But it will end. Everything ends. And the timeline of that ending is something that should fundamentally change the way you think about existence. So let us take a journey, not through space, though we will pass through space along the way, but through time. Deep time. The kind of time that makes the age of the universe look like a warm-up act. We are going to travel to the end of everything, and I promise you, what we find there will be unlike anything you have imagined. The first thing you need to understand is that the universe is not static. It is not a fixed stage on which events play out. It is itself a dynamic, evolving, changing thing. Right now, as you sit wherever you are sitting, every galaxy in the observable universe is moving away from every other galaxy. The universe is expanding. And not just expanding, it is accelerating. Something called dark energy, which we do not fully understand and cannot directly observe, is pushing everything apart faster and faster. The galaxies are not flying apart because of some initial explosion that sent them scattering. They are being pushed, actively, continuously, relentlessly pushed apart by a force that permeates all of space and seems to grow stronger as space itself grows larger. What does this mean for the long-term future? It means that the universe is becoming lonelier. Right now, on a clear night, you can see the Andromeda Galaxy with the naked eye. A faint smudge of light in the constellation Andromeda, 2.5 million light-years away. It is the most distant thing the human eye can see without a telescope. In roughly 4.5 billion years, Andromeda will collide with our own Milky Way in a slow, majestic cosmic merger that will reshape both galaxies entirely. But here is the thing. Even as our local group of galaxies merges and consolidates, the rest of the universe is racing away from us. The galaxies beyond our local group are already moving away faster than light, not because they are travelling through space faster than light, but because space itself is expanding between us and them. They are not breaking any laws of physics. They are simply being carried away on the expanding fabric of space-time, and eventually they will cross what physicists call the cosmological event horizon. Once they cross that line, no signal from them can ever reach us again. They will be gone, not destroyed, just forever unreachable, forever invisible, forever lost. In about 150 billion years, a number so large it makes the current age of the universe look trivial, the night sky will be almost completely dark. Every galaxy beyond our local group will have crossed the horizon. The universe will appear to consist of nothing but our own merged galaxy, a vast island of stars surrounded by an infinite, empty, expanding void. Future astronomers, if any exist, will look out at the sky and see nothing. No distant galaxies, no evidence that the universe is vast and full of structure. They will have no way of knowing what we know now. The evidence will be gone. The universe will have hidden its own history. But our galaxy will still be there. The stars will still be burning. Life might still be possible. So let us keep going. Stars are not eternal. This is something we know with absolute certainty, and yet it is something that the human mind resists accepting. The sun has been burning for about 4.5 billion years, and it has roughly another 5 billion years left before it exhausts its hydrogen fuel and begins to die. When it does, it will expand into a red giant, swallowing Mercury and Venus and possibly Earth, before shedding its outer layers and leaving behind a dense, cooling remnant called a white dwarf. This is the fate of most stars. Not a dramatic explosion, but a slow, quiet fade-in. A white dwarf is essentially a stellar corpse. It no longer generates energy through nuclear fusion. It simply radiates away the heat it has stored, cooling over billions and billions of years, until eventually, in a time frame almost beyond comprehension, it becomes a cold, dark object called a black dwarf. I say almost beyond comprehension, because the timescale for a white dwarf to cool into a black dwarf is roughly 1 quadrillion years, That is a 1 followed by 15 zeros. The current age of the universe is 13.8 billion years. A 1 followed by 10 zeros. So a black dwarf takes roughly 100,000 times longer to form than the universe has currently existed. And here is the haunting part. No black dwarfs exist yet. The universe is not old enough. Every white dwarf that has ever formed is still glowing, still warm, still radiating the last of its stored energy into the void. The first black dwarfs will not appear for an almost incomprehensible stretch of time into the future. But they will appear, and when they do, they will be the cold tombstones of stars that once burned bright enough to warm planets, to drive weather systems, to make photosynthesis possible, to make life possible. But before we get to black dwarfs, let us talk about what happens to the stars that are still burning. Because the story of the universe's future is not just about individual stars dying. It is about the process of star formation itself coming to an end. Stars form from clouds of gas and dust, primarily hydrogen, that collapse under their own gravity. When enough material comes together and the pressure at the center becomes high enough, nuclear fusion ignites and a new star is born. This process has been happening continuously since the early universe, and it is still happening today. Right now, somewhere in our galaxy, new stars are being born. But the raw material for star formation is finite. Every time a star forms and burns and dies, some of that hydrogen is converted into heavier elements and locked away in stellar remnants. Some is ejected into space, but not all of it returns to the cycle. Slowly, over vast timescales, the universe is running out of the fuel needed to make new stars. Astronomers estimate that the peak of star formation in the universe occurred about 10 billion years ago. Since then, the rate of new star formation has been declining. We are already past the golden age of stars. The universe is, in a very real sense, winding down. In roughly 100 trillion years, 10,000 times the current age of the universe, the last new stars will form. After that, no new stars will ignite. The existing stars will continue to burn through their remaining fuel, but when they die, nothing will replace them. The galaxy will grow darker, one star at a time, over a period of trillions upon trillions of years, until the last star, a small dim red dwarf burning its hydrogen with extraordinary efficiency, finally exhausts its fuel and goes dark. Think about that for a moment. The last star. There will be a last star. Not a metaphorical last star, not a poetic last star, but a literal, physical, actual last star. The final point of light in a universe that was once filled with hundreds of billions of galaxies, each containing hundreds of billions of stars. And when that last star goes out, the universe will enter a darkness unlike anything that has existed before. Not the darkness of night, which is broken by starlight. Not the darkness of deep space, which is filled with the glow of distant galaxies. A true, absolute, total darkness. The darkness of a universe in which no nuclear fusion is occurring anywhere. The darkness of a universe that has, in a very real sense, used up its youth. But even then, the story is not over, because the universe will still exist. It will just be a very different kind of place. After the last star dies, the universe will be populated primarily by stellar remnants. White dwarfs cooling toward black dwarfs, neutron stars spinning in the dark, and black holes. Black holes are perhaps the most fascinating objects in the universe, and they will outlast everything else by an almost incomprehensible margin. A black hole is a region of space-time where gravity is so strong that nothing, not matter, not light, not information, can escape once it crosses the event horizon. They form when massive stars collapse at the end of their lives, and they can also form through other processes, including the mergers of smaller black holes. The supermassive black hole at the center of our galaxy, called Sagittarius A star, has a mass of about 4 million times that of the Sun. The supermassive black hole at the center of the galaxy M87, which was famously photographed in 2019, has a mass of about 6.5 billion solar masses. For a long time, physicists assumed that black holes were truly eternal, that once matter fell in, it was gone forever, locked away behind the event horizon for the rest of time. But in 1974, Stephen Hawking made one of the most remarkable theoretical discoveries in the history of physics. He showed that black holes are not truly black. They emit a faint radiation, now called Hawking radiation, as a consequence of quantum mechanical effects near the event horizon. This radiation carries energy away from the black hole, which means the black hole is slowly losing mass. Very, very slowly. The rate of Hawking radiation is inversely proportional to the mass of the black hole. The more massive the black hole, the slower it evaporates. A black hole with the mass of our Sun would take about 2 × 10 to the power of 67 years to evaporate completely. The supermassive black hole at the center of M87 would take roughly 10 to the power of 100 years. These are numbers that make the age of the universe look like a rounding error. But they will evaporate. Eventually. Given enough time, and the universe has nothing but time, even the most massive black holes will slowly, particle by particle, quantum by quantum, radiate away their mass and disappear. And when the last black hole evaporates, what is left? What does the universe look like after every star has died, every white dwarf has cooled, every neutron star has decayed, every black hole has evaporated? This is where we reach the territory that physicists call the Dark Era. And it is here that the story becomes truly strange. After the last black hole evaporates, the universe will consist primarily of photons, particles of light, and a scattering of subatomic particles, electrons, positrons, neutrinos. These particles will be spread so thinly across such an incomprehensibly vast space that the average distance between any two particles will be larger than the current observable universe. The universe will be cold, just barely above absolute zero, the theoretical minimum temperature. It will be dark. It will be almost perfectly uniform. And it will be expanding still, driven by dark energy, growing larger and emptier with every passing moment. Is this the end? Is this what the universe becomes? An infinite, cold, dark, nearly empty expanse of slowly cooling radiation. Many physicists think so. This scenario is sometimes called the heat death of the universe, though the name is a bit misleading. It is not death by heat, but death by the absence of heat, by the equalization of temperature across all of space, by the achievement of maximum entropy. Entropy is a measure of disorder, of the number of possible arrangements a system can be in. The second law of thermodynamics tells us that entropy always increases in a closed system. The universe is, as far as we know, a closed system, and so its entropy has been increasing since the Big Bang, and will continue to increase until it reaches its maximum possible value, a state of perfect featureless equilibrium in which nothing can happen, because there are no gradients of temperature or energy left to drive any process. In this state, time itself becomes meaningless, not because time stops, but because nothing changes. If nothing changes, there is no way to distinguish one moment from the next. The universe will exist, technically, but it will be a universe in which nothing ever happens again. A universe of pure, static, eternal sameness. And yet, and this is where it gets truly mind-bending, even this might not be the final word. Quantum mechanics tells us that even in a state of maximum entropy, fluctuations are possible. Random, spontaneous, unpredictable fluctuations in the quantum fields that permeate all of space. Most of these fluctuations are tiny and inconsequential. But given enough time, and we are talking about timescales that make the evaporation of black holes look instantaneous, a fluctuation of any size is possible, including, theoretically, a fluctuation large enough to spontaneously produce a new Big Bang, a new universe born from the quantum noise of a dead one. This idea is sometimes called the Boltzmann brain problem, after the 19th century physicist Ludwig Boltzmann, who first grappled with the implications of entropy and fluctuations. The idea is this. If you wait long enough in a universe of maximum entropy, random fluctuations will eventually produce any configuration of matter and energy, no matter how complex, including, for example, a single brain, a Boltzmann brain, that spontaneously assembles itself from the quantum vacuum, complete with false memories of a life that never happened, existing for a brief moment before dissolving back into chaos. Or, on a much larger scale, an entire universe, complete with its own history and its own laws of physics, spontaneously fluctuating into existence. The timescale for such an event is so large that it cannot be written in standard notation without filling pages with zeros. But in a universe with infinite time, even the most improbable event becomes not just possible, but inevitable. And this raises a question that is simultaneously profound and deeply unsettling. How do you know that you are not a Boltzmann brain right now? How do you know that your memories are real, that the universe you perceive has actually existed for 13.8 billion years, rather than having spontaneously fluctuated into existence a moment ago, complete with the illusion of history? You cannot know, not with certainty. This is not a comfortable thought, but it is a legitimate scientific question, and the fact that it is a legitimate scientific question tells you something important about the nature of reality and the limits of what we can know. But let us step back from the philosophical abyss for a moment and return to something more immediate, because the journey to the end of time is not just a story about physics. It is a story about meaning, about what it means to exist in a universe that is, on the longest timescales, heading toward silence and darkness, about what it means to be alive, conscious, aware, in the brief cosmic morning of a universe that will outlast us by an almost infinite margin. Here is something that I find both terrifying and beautiful in equal measure. Every atom in your body was forged in the heart of a star. The carbon in your cells, the oxygen in your lungs, the iron in your blood. All of it was created by nuclear fusion in stars that lived and died billions of years before the sun was born. You are, in the most literal possible sense, made of stardust. The universe created you. And when you look up at the night sky and feel that strange, wordless connection to the stars, you are not being sentimental. You are recognizing something real. You are the universe looking at itself. You are the cosmos becoming aware of its own existence. And that awareness, consciousness, self-reflection, the ability to ask questions and seek answers, is, as far as we know, the most remarkable thing the universe has ever produced. In 13.8 billion years of cosmic history, in a universe containing hundreds of billions of galaxies, each containing hundreds of billions of stars, the only place we know for certain that consciousness has arisen is here, on this small rocky planet, orbiting an unremarkable star in the outer arm of an average galaxy. Maybe consciousness has arisen elsewhere. Maybe the universe is teeming with minds. But we do not know that. What we know is that it happened here, that the universe, through a process of almost incomprehensible complexity and improbability, managed to produce beings capable of understanding it. And now those beings, us, have looked at the universe and worked out its future. We have traced the trajectory of stars and galaxies and black holes and quantum fluctuations, and we have arrived at a picture of the deep future that is, in many ways, bleak. The stars will go out. The black holes will evaporate. The universe will grow cold and dark and empty. Everything we know and love and value will be gone, not just forgotten, but physically erased, scattered into a thin soup of particles and radiation expanding forever into an infinite void. Does that make life meaningless? Does the fact that everything ends, not just individual lives, not just civilizations, not just species, but everything, the entire universe, does that make the present moment less real, less valuable, less worth living? I do not think so. And here is why. The fact that the stars will eventually go out does not diminish the light they give right now. The fact that the sun will eventually expand and swallow the earth does not make the warmth on your face on a summer afternoon any less real. The fact that every human being who has ever lived has died, and every human being who will ever live will die, does not make love less powerful, or beauty less real, or kindness less meaningful. Impermanence is not the enemy of value. In many ways, it is the source of value. We treasure things precisely because they do not last forever. We love people more fiercely because we know we will lose them. We pay attention to sunsets because we know they end. The universe is telling us something with its long, slow journey toward darkness. It is telling us that existence is not a given. It is not the default state of things. The default state of things is nothing. The cold, empty quantum vacuum from which everything briefly, improbably, magnificently arose. The fact that there is something rather than nothing. The fact that the laws of physics are what they are, and not something else. The fact that those laws allowed hydrogen to form, and stars to ignite, and planets to coalesce, and life to emerge, and consciousness to awaken. All of this is, from a certain perspective, a miracle. Not a supernatural miracle, but a natural one. The miracle of existence itself. And we are part of that miracle. We are not observers of the universe. We are the universe. We are the part of the universe that has become aware of itself, that has looked at the stars and asked where they came from and where they are going. We are the part of the universe that has felt wonder and grief and love and curiosity. We are the part of the universe that has written poetry and built cathedrals and composed symphonies and launched spacecraft and peered through telescopes at the farthest reaches of space and time. And now we have done something even more remarkable. We have looked at the future, not just the near future, the next election, the next decade, the next century, but the deep future, the future of stars and galaxies and black holes, the future of the universe itself. And what we have found is not comforting, exactly, but it is honest. And there is a kind of beauty in honesty, even when what is honest is hard. Let me tell you about the last star. Not metaphorically, literally. The last star that will ever burn in this universe will almost certainly be a red dwarf. Red dwarfs are the smallest, coolest, most numerous stars in the galaxy. They burn their hydrogen so slowly and so efficiently that they can live for trillions of years. The smallest red dwarfs, stars with about 8% of the mass of the Sun, will burn for roughly 10 trillion years. That is roughly 700 times the current age of the universe. These stars are so dim that they are invisible to the naked eye, even the nearest ones. They are the quiet, patient, unassuming workhorses of the stellar world, burning steadily in the dark while their more massive, more brilliant cousins burn bright and die young. The last of these red dwarfs will burn for an almost incomprehensible length of time. And when it finally exhausts its hydrogen fuel, it will not explode. It will not go supernova. It will simply stop. The nuclear reactions at its core will cease. The outward pressure that has been balancing gravity for trillions of years will disappear. The star will contract slowly into a white dwarf, a dense, hot ball of carbon and oxygen roughly the size of the Earth, glowing with the residual heat of its long life. And then it will cool. Over quadrillions of years it will radiate away its heat, growing dimmer and dimmer until it is no longer visible, no longer warm, no longer anything but a cold, dark, inert sphere drifting through an empty universe. And that will be it. That will be the last light, the last warmth, the last nuclear fire in a universe that was once ablaze with hundreds of sextillions of stars. After that, there will be no more starlight, no more photosynthesis, no more weather driven by solar energy, no more life as we understand it. Just the slow, cold, dark expansion of a universe that has used up its stars and is now coasting toward maximum entropy, on a timescale that makes all of previous cosmic history look like a brief, bright flash. I want you to sit with that image for a moment. The last star going dark. Not with a bang, not with a dramatic final explosion, but with a quiet, gradual fading. The last photons of starlight travelling outward into an empty universe, growing redder and dimmer as the expanding space stretches their wavelengths, until they are so long and so faint that they carry essentially no energy at all. The universe going dark, not all at once, but one star at a time, over trillions of years, until the last one is gone. Is there anything more lonely than that image? Is there anything more final? And yet, and I keep coming back to this, we know about it. We, the brief, improbable, magnificent products of stellar nucleosynthesis and planetary chemistry and biological evolution have figured this out. We have looked at the universe and understood its trajectory. We have done the math. We have traced the physics. We have imagined the last star. And in imagining it, we have done something that no other process in the universe, as far as we know, has ever done. We've given the universe a witness to its own ending. There is a concept in physics called the observer effect, the idea that the act of observation changes what is observed. In quantum mechanics, this is a literal, physical effect. But there is a broader, more philosophical sense in which observation matters. A universe that is never observed, never understood, never contemplated. Is it really the same as a universe that is? Does the universe's story mean anything if there is no one to hear it? I am not suggesting that consciousness is necessary for the universe to exist. The universe existed for billions of years before any conscious being arose to observe it, and it will exist for trillions of years after the last conscious being is gone. But I'm suggesting that consciousness adds something, that the universe, knowing itself, even briefly, even imperfectly, even through the limited and fallible minds of creatures like us, is not nothing. It is something. It might even be the most important something that has ever happened. Because here is the thing about the end of the universe. It is not happening now. It is not happening soon. On any time scale that matters to a human life, or a human civilization, or even a human species, the universe is not ending. The stars are burning. The galaxies are spinning. Life is possible. Consciousness is possible. The future is open. We are not at the end of the story. We are at the beginning. We are in the first chapter of a book that will run for trillions of pages, and we happen to be the part of the story that became aware of itself. What do we do with that? What do we do with the knowledge that we are brief and fragile and temporary, that everything we build will eventually be erased, that the universe is heading toward a darkness we cannot prevent? I think we do what humans have always done when confronted with the vastness and indifference of the cosmos. We look at each other, we reach out, we build things, we tell stories, we ask questions, we love, we grieve, we wonder, we persist. The stars do not care about us. The universe does not care about us. There is no cosmic plan, no divine purpose, no guarantee that consciousness will survive or that anything we do will matter on the longest timescales. But we care. We care about each other, about the truth, about beauty, about justice, about the future. And that caring, that capacity for meaning-making in a universe that does not provide meaning ready-made, is perhaps the most extraordinary thing that has ever emerged from the quantum foam of the Big Bang. You are made of atoms that were forged in stars that died billions of years before you were born. You are the product of an evolutionary process that has been running for nearly 4 billion years on this planet. You are the heir to a cultural tradition that stretches back hundreds of thousands of years, through every civilization and every language and every story that has ever been told. You carry within you the accumulated wisdom and folly and beauty and horror of everything that has ever lived and thought and felt on this small, improbable world. And you are alive right now, in this moment, in this brief cosmic morning, when the stars are still burning and the universe is still young enough to support life and consciousness and wonder. That is not nothing. That is everything. The last star will go dark. The black holes will evaporate. The universe will grow cold and empty and silent. But right now, in this moment, there is light. There is warmth. There is life. There is you reading these words, thinking these thoughts, feeling whatever you are feeling. And that, the fact that the universe has produced a being capable of contemplating its own ending, is, I think, the most remarkable fact in all of physics. We are the universe's way of knowing itself. We are the cosmos made conscious, and even if that consciousness is brief, even if it is fragile, even if it is destined to end, it happened. It is real. It matters. The last star in the universe is still billions of trillions of years away from going dark. Between now and then, there is time. Time for everything. Time for mistakes and corrections, for failures and recoveries, for questions and answers, for love and loss, and everything in between. Time for us to become something we cannot yet imagine. Time for the universe to surprise us, as it has always surprised us, with possibilities we never anticipated. So look up at the night sky. Look at the stars. Know that they are burning right now, in this moment, fusing hydrogen into helium, pouring light and heat into the void, making life possible on at least one small planet in at least one unremarkable galaxy. Know that they will not burn forever. Know that the universe is heading slowly and inexorably toward a darkness we cannot prevent. And then, and this is the important part, know that you are here, now, in the light, in the warmth, in the brief, brilliant, improbable morning of a universe that somehow, against all odds, managed to produce something capable of knowing that it exists. That is the story of the last star. Not just the story of its death, but the story of everything that came before it. Every galaxy, every sun, every planet, every ocean, every cell, every thought, every dream. The story of how the universe went from nothing to everything, and how everything will eventually return to something very close to nothing. And the story of how, somewhere in the middle of that vast arc, for a brief and shining moment, the universe woke up and looked at itself and said, I am here. I exist. I wonder. What happens after the last star goes dark, we cannot know for certain. Perhaps the quantum fluctuations of an empty universe will eventually produce something new. A new Big Bang, a new cosmos, a new story beginning where this one ends. Perhaps the cycle of creation and destruction is eternal. Universes blooming and fading like flowers in an infinite garden of space-time. Perhaps there is something beyond what our physics can currently describe, some deeper structure of reality that we have not yet glimpsed, some twist in the story that changes everything we think we know about the ending. Or perhaps not. Perhaps the darkness is final. Perhaps the last star going dark is truly the last word, the final period at the end of the longest sentence ever written. Perhaps the universe has one story to tell, and it is telling it right now. And when it is done, it will be done. Either way, we are here for the telling. We are the part of the story that knows it is a story. And that, in the end, is the most astonishing thing of all. The universe began with a flash of light so intense that it created space and time themselves. It will end, if our physics is correct, in a darkness so complete that not even the concept of darkness will have meaning. because there will be nothing left to experience the absence of light. Between that beginning and that ending, there is everything. Every star, every planet, every ocean, every forest, every city, every face, every voice, every song, every question, every answer, every moment of joy, and every moment of grief, and every moment of quiet wonder when you look up at the sky and feel for just a second that you understand something true about the nature of things. We are that understanding. We are the universe's brief, beautiful, improbable attempt to know itself. And even if we are the only such attempt, even if consciousness is a cosmic accident that happened once and will never happen again, it happened. We happened. And the fact that we happened, the fact that the universe produced beings capable of tracing its history and imagining its future and feeling the weight of both, is not a small thing. It is the largest thing there is. The last star is waiting, somewhere in the deep future, patient and dim and inevitable. But it has not gone dark yet, and until it does, there is still time to look up, to wonder, to reach out, to connect, to build, to love, to ask the questions that have no answers, and to sit with the mystery of existence without flinching. There is still time to be alive in a universe that is alive, to be conscious in a cosmos that has somehow miraculously become conscious of itself. That is enough. That is more than enough. That is everything.